Okay, some quick notes on Logisim for the control lab for the CPU. So the first thing to note, if you think back to last week, we're going to open inside datapath32. Last week we worked with datapath.circ. We filled out the data path. We sort of had everything set here. And you remember up here with control, if we open this up, it's actually fake control. The opcode comes in, but it gets ignored. We have this override code, which we're manually setting for different instructions. What we're going to do this week is we're going to do the actual control. Now you notice over here you've got all the Logisim built-in stuff. You've also got CPU 32, miscellaneous 32, and control. These are the circuits going to work with. But if we open them from inside here and set up their truth tables from inside here from datapath 32, it's not going to work. Instead, you actually need to open control.circ as a separate thing. Now, remember back we had this fake control and this fake ALU. We also have control and then ALU control. These are the circuits, sort of take the inputs. This stuff here, this is what does all the work. Alright, this is ALU control. If we look at that, that's ALU control 0. That's this circuit. For control, this is control 0. This is control 1. As you can see, control 1 takes the opcode, figures out the 2-bit ALU override. Control 0, this takes the opcode and then sets all the control signals. Now the way we're going to set these, if you go up here for example to control 0, we've got our inputs, and then here we've got our control line outputs. Now what we're going to do for this here in Logisim, we're going to say project, analyze circuit, table. This brings up the truth table. So we know, for example, all zeros here, that means it's R-type. So I set these for whatever it needs to be for R-type. I'm just making this up. These are, this is probably not correct. So now this would be my settings for R-type. Now, a lot of these inputs, we don't care what the output circuit is, right? What is instruction 000001? I have no idea. If I look at my Word document, which you should already have filled out. If you haven't, go ahead and fill it out. These are the only opcodes I care about. This opcode isn't one of them, so I don't care what it does, therefore I leave it all X'd. So you actually just have to go find these particular opcodes and then set everything accordingly. Not actually terribly difficult. When you're done with all of that, there's only going to be a few rows that aren't all X's. You'll click Build Circuit. It'll build a circuit, tell it to go ahead and put it into control 0, and you'll have a nice little circuit here. If you then go over here to control, that circuit you've generated, it's going to replace this, right? If we right-click on this, this is in fact control 0. Now your incoming opcode is going to set everything correctly. Now as soon as you've done that, you need to test it. You need to go ahead and set these to these different opcodes that you care about. Make sure that you're getting the right outputs. If you're not, check your truth table, adjust it as necessary, rebuild the circuit. It's very easy to debug things here. It's very hard to debug things with the entire data path. Now you're going to do the same thing with control 1. Control 1's actually pretty easy as well. These are just the 2-bit override codes. Those don't actually show up here. We didn't fill them in. But if you look down here, you can pretty easily figure out what these override codes need to be. R-type, you can figure out what that is, and so on. There's only, again, if we go over here, project, analyze circuit, we look at table, there's only going to be a few rows that are filled out because there's only a few inputs we care about. Again, there's a whole bunch of opcodes here. We don't care about most of them. Now, control 0, control 1, not super difficult. ALU control 0, actually a little bit more difficult. If you look at this, this has two different inputs, the 2-bit ALU code and the 6-bit function code. This one's a little trickier. So we're going to do analyze circuit, we're going to bring up table. Now we've got this conundrum. We know that ALU op 00, that's the override code. That means that we always want the ALU to add. So what we're going to do is set this to add, whatever the code happens to be. Suppose it's this. It's actually not that, but suppose it is. But now we need that for all of these 00s. Now the problem with Logisim, I actually don't care about any of these function codes, but these are inputs. Logisim only lets you X outputs. So instead, we've got to do some copy-paste work. Oh, that was weird. Let me try that again. Copy, paste, paste. Yeah, so we sort of paste this a line at a time. And then if you have a whole bunch of them, you can actually copy the whole thing, go ahead and paste the whole thing, and and so on. You keep doing that until you've got all of these filled. Now again, this isn't actually the correct code. I just stuck in some random stuff here. You'll have to check and make sure yours are correct. So that'll get us ALU op 0, 0. Should always have the same output to the ALU 0, 1. Should always have the same output to the ALU 1, 0. That means R type, so you're going to have to find the particular 6-bit function codes that we care about for R type, and then make sure we've got the correct instruction going to the ALU for each of those. And then for 1, 1, we're actually adding a new instruction the book doesn't talk about. 1, 1 is actually unused as a 2-bit override code. We're going to say 1, 1 is going to do SLTI. We're going to have this instruction for set less than that uses an immediate value. So we can go ahead and set that up. And once again, 1, 1 is always going to do SLT, so you would set this as appropriate and you would do a bunch of cutting and pasting and then build the circuit. A couple of other quick notes. When you're working on this, suppose you get a bunch of work done and then you want to go work on something else. There's no way to save this. You actually have to finish it and then build the circuit, otherwise the truth table goes away. So don't think that you can put some stuff in here and then close this, because if you look and go back over here, analyze circuit, go back to table, oh crap, all my work's gone. So you've got to make sure you finish everything. Some other notes, you got your inputs, you got your outputs. You could rearrange these, but don't. The circuit's going to expect them to be in a certain order. The expression here, it's actually going to try to show you this is Boolean algebra. That's actually really cool. I have no idea what this does, so I'm not going to worry about it. So basically, we're just filling out the truth tables, generating the circuits. Once you've got this control finished, save it, and then go back here, close and reopen your data path, and then delete your control and delete your ALU control. Go in here to control, replace these. This is actually fake control, and this is actually fake ALU control because you're using these overrides coming from down here where we sort of hard-coded values. Go ahead and delete those. Replace them with the real control and the real ALU control, and then you should be able to run real instructions with your 32-bit CPU. Awesome. Thanks for listening.